till now, all the programs that you have been asked to write in your assignments have actually been just functions. So these are functions which are called from other pieces of Python code and return values to them. Now, when you have a standalone Python program, it must interact with the user in order to derive inputs and produce outputs. So let's see how Python interacts with its environment. The most basic way of interacting with the environment is to take input from the keyboard and display output to the screen. Traditionally, these modes are called standard input and standard output. So standard input just means take the input from the keyboard or any standard input device like that, and standard output just means display the output directly on the screen. So the basic command in Python to read from the keyboard is input. So if we invoke the function input with no arguments and assign it to a name, then the name user data will get the value that is typed in by the user at the input command. So remember that it reads a line of input. So the way that the user signals that the input is over is by hitting the return button on the keyboard. And the entire sequence of characters up to the return, but not including the return, is transmitted as a string to user data. Now, of course, if the program is just waiting for you for input, it can be very confusing. So you might want to provide a prompt, okay, which is a message to the user telling the user what is expected. So you can provide such a thing by adding a string as an argument to input. So if you put an argument to input like this, okay, then it is a string which is displayed when the user is supposed to input data. Now this string is displayed as it is, so you can make appropriate adaptations to make it a little more user friendly. We will see an example in a minute, but you might want to leave a space or you might want to insert a new line. Okay, so basically you use the input command to read one line of input from the user, and you can display a message to tell the user what is expected of him. So here is what happens if I just say user data is equal to input. The Python program will just wait, and now as a user who doesn't know what is expected, we don't know whether it's processing something or it's waiting for input. Now it so turns out that if we type something and press enter, it will come back, and now if I ask for the contents of the name user data, it will in fact be the string of things that I typed. So providing an input prompt without a message can be confusing for the user. So what we said was we might want to say something like provide an input like this. So now it provides us with a message, but the number that we type, for instance, is stuck to the message, so it's not very readable. So user data is indeed not a number, now it's a string, as we will see in a minute. But the fact is that we didn't get any space or anything else, so it looks a bit ugly. So what we said is that you can actually, for instance, put a colon and a space so that the message comes like this, and now this is a slightly nicer prompt. And you could also put a new line if you want, which is signaled by this special character \n. So now the message comes and then you type on a new line, right? And in all cases the outcome is the same. User data, the name to which you're reading the input, becomes set to the string that is typed in by the user. So if I do it again and if I type in something else like 993 for example, then user data becomes the string 993. So you can use input with a message and make the message as readable as you can. So as we saw when we were playing with the interpreter, the input that is read by the function input is always a string. So even if you say enter a number and the user types in a number, this is not actually a number. So if you want to use it as a number, you have to use this type conversion. Remember, we have these functions int, str, and so on. So we have to use the int function to type convert whatever the user has typed to an integer. Now, of course, remember that if the user types some garbage, then you get an error, right? So the user doesn't type something valid, then you will get an error. So what we can do is we can use exception handling to deal with this error. So what we can say is try user data. So this is the code that we had before, those two lines. So what we want to say is we will try these lines, but if the user types something which is not a number, then we're going to ask them to type it again. And it will turn out that that type of error in Python is called a value error. So you can verify this by going to the Python interpreter and checking. So in the Python interpreter, if we try to apply int to some nonsensical thing, then we get a value error. So what we are trying to say is that if we get a value error, we want to take appropriate action. So we have this try block, and if we see a value error, what we do is we print a message. Now we are going to see print just after this, but we print a message to the user saying this is not a number, try again. And this is now, the whole thing is enclosed inside a while loop, and this while loop has the condition true. In other words, the condition is never going to become false. This while loop is going to keep on asking for a number, right? So how do we get out of this? Well, if I come here and I get a value error, it will go back, okay, and the while will execute again. But if there is no error, remember, if there is no error here, then it will come to the else, right? So this else is executed if there's no error, and what the else does is it gets us out of this vicious cycle. So in other words, we are in an infinite loop where we keep on trying to get one more piece of data from the user until we get something that we like, and when we get that, we break out of the loop, right? So this is another kind of idiomatic way to use exceptions in the context of input and output. As we said in the last lecture, input and output is inherently error prone because you're dealing with an uncertain interacting environment which can do things which you cannot anticipate or control. So you must take appropriate action to make sure that the interaction goes in the direction that you expect. So the other part of interaction is displaying messages, which we call standard output or printing to the screen. And this is achieved using the print statement, which we have seen occasionally informally without formally having defined it. So the basic form of the print statement is to give a sequence of values separated by commas. So print xy will display the value of x, then a space, then the value of y. Okay. Print abc will display three values, the values of a, b, and c separated by spaces. Now, the other thing that we can do is directly print a string or a message. So like we saw in the previous example, we can say print the string, not a number, try again. So this will display the string on the screen. Now you can combine these two things in interesting ways. So print takes in general a sequence of things of arbitrary length separated by commas. So these things could be either messages or names. So we can say things, supposing we want to print the value of x and y, but we want to indicate to the output which is x, which is y. So instead of saying just print x comma y, which produces two values on the screen with no indication as to which is x and which is y, we could have this more elaborate print statement which prints four things. So the first thing it prints is a message saying the values are x colon. So this will print x colon and leave a space. Then it will print the current value of x. Then it will print y colon after a space. And then it will print the current value of y. So we can intersperse messages with values, okay, with names to produce meaningful output that is more readable. By default, print appends a new line whenever it is executed. In other words, every print statement we just print the way we have done so far appears on a new line because the previous print statement implicitly moves the output to a new line. Now, if we want to control this, we can use an optional argument called end. So we can provide a string saying this is what should be put at the end of the print statement. By default, the value here is this new line character. Okay, so we can replace this by something else. So here is an example. Supposing we write these three statements. So the first statement says print continue on the, this is just a string, but set end to a space. The second line says print same line, and then it says set end to a full stop and a new line. And then the third statement says print next line. Okay. So what we are doing is in the first two statements, we are changing the default. So the default would have been to print a new line, but the first statement is not printing a new line. So if we print this, what we see is that the first two statements continue on the and same line come on a single line because we have disabled the default print new line. And we have explicitly put a new line here, and this has forced the next one to come on the next line. So if we break this up and see what happens here, we see that in the first statement we had this end which says insert a space. And this is why we get a space between the word the in the first line and the word same coming from the second line. Otherwise, the and same would have been fused together as a single word. Right? So end equal to space is effectively separating this print from the next print by a space. The next print statement inserts a full stop and a new line. So implicitly, although the word same line ends without a full stop, we produce a full stop, and after we produce a full stop, it produces a new line. And finally, after this new line, the next line comes on a new line. And of course, because here we didn't say anything, if we print after that, we implicitly would print on a new line. The other thing that we might want to control is how the items are separated on a line. We said that if we say print x comma y, then x and y will be separated by a space by default. Right? So if we do this, print x, y, we set x equal to 7, y equal to 10, and we say x is x and y is y, and then we want to end with a full stop. Right? So this is what we want. You want to write the string x is, then the value of x, and y is, then the value of y, and then a full stop. Now, because everything is separated by space, what we find is that we find a space over here. So do you see this? So this is fine. So we get a space here because that is from this comma. We get a space here, which is from this comma. We get a space here, which is from this comma. And then we get an unwanted space between 10 and the full stop. So how do we get rid of this space, the second space? Right? We don't want a full stop to come after a space. So just like we have the optional argument end, we have an optional argument sep, which specifies what string should be used to separate. So for example, if we take the earlier thing, we can say don't separate it with anything. Now of course don't separate it with anything is dangerous because then this x is 7 will get fused and this and will get fused. So what we do instead is we put the space explicitly here. Okay? So so earlier we had no space here at the end, just around the quotes. Now we put spaces where we want them, and we say don't put any other spaces. So what this will say is that x is space, I give the space. Don't put a space, put the value of x. Don't put a space, now I give a space. So and y is give a space. Then now don't put a space here. So these commas don't contribute any space because I've said separator should be empty. And in particular, what this means is that this last comma, okay, the comma between the y and the full stop will not generate a space. And in fact, if you execute this, then you will get the output x is 7 and y is 10. And the way it works is that this is the first block, right? So this is everything up to here. Then this is the second block. This is this. Then this is the third block, which is this whole thing with the spaces given. And then this is the value of y. And finally, this is the full stop, right? So this is one way to control the output of a print statement. So with the optional arguments end and sep, we can control when successive prints continue on the same line, and we can control to some limited extent how these values are separated on a line. But we may actually want to do a lot more. We might want to put a sequence of things so that they all line up. Right? So supposing we want to print out a table using a print statement, we want to make sure that the columns line up. So we might want to say that each item that we want to print, like we are printing a sequence of numbers line by line, but the numbers may have different widths. Some may be 3 digits, some may be 5 digits. We might say print them all to occupy 7 characters width. Right? So this is a thing that we might want to do, align text. Now within this alignment, we might want to align things left or right. So if we have a default with say 10 characters, if they are numbers, we might want them right aligned so that the units digit is aligned up. If they are names, we might want them left aligned so that we can read them from left to right without it looking ragged. And if we are doing things like calculating averages or something, we may not want the entire thing to be displayed. We might want to truncate it to 2 decimal points, say it is currency or something like that. So these are all more intricate ways of formatting the output, and we will see in the next lecture how to do this. But right now you can use end and sep to do minimal formatting. So to summarize, you can use the input statement with an optional message in order to read from the keyboard. You can print to the screen using a print statement. Now, we mentioned at the beginning that there are some differences between Python 2 and 3. And here is one of the more obvious differences that you will see if you look at Python 2 code, which is available from various sources. In Python 2, you can say print space and then give what is given as the arguments to print in Python 3. So Python 3 insists on it being called like a function with brackets. In Python 2, the brackets are optional. So you will very often see in Python 2 code something that looks like print xy, okay, without any brackets. This is legal in Python 2. This is not legal in Python 3. So just be careful about this. And what we saw is that with a limited amount of control, we can make print behave as we want. So we can specify what to put at the end. In particular, we can tell it not to put a new line, so continue printing on the same line. And we can separate the values by something other than the default space character.